One last thing that we're going to be looking at is going to be how this electromotive force works inside of a speaker. So this is the general structure of a speaker, and again, it involves a copper wire and some type of magnet. So imagine that you have a speaker, and here's going to be the opening of the speaker, or the cone of the speaker. And then the speaker kind of narrows down like this. And then what you can't usually see is this part on the back of the speaker. And what you also will have is you'll have some type of magnet. Sometimes it's attached to the speaker, and sometimes the magnet will be next to the speaker like this. But imagine here's the north, and then here is the south. So we've got our magnetic field lines coming out like this. Okay, kind of going like this. Well, what happens is you have some type of wiring, and this wiring goes around this base like this. And just like the nail, remember that it kind of goes over and then curls around and then goes over and then curls around and then goes over, and then we'll just kind of do this right here. Let's take a look and see the direction of the current. So here's the wire, and let's say the current is moving in this direction. Okay, it goes through the coil or the solenoid, and then it's going to come out. Lost my light. And then it's going to come out, and so the current's going to be running in this direction like this. So let's see what type of temporary magnet is going to be created with this wiring. So remember, if the current, we're following the second-hand rule, the current is running over the speaker like this, therefore it's going to set up a temporary magnet of a north and a south. So again, here's our solenoid. This is going to be creating that temporary magnet. So when we put the current in this direction, what's going to happen? It's going to be pulled in. So this is going to be an attractive force. So it's going to be, speaker's going to be pulled in. So the speaker goes in. If you reverse the current, okay, what's going to happen is then the current's going to run through this way, okay, and then it's going to come out the other way. What's going to happen in that scenario is, so when we reverse current, okay, we're going to create the electromagnet and the temporary magnet in the opposite direction. So you're going to create, I'm just going to draw a magnet here. This is going to be your south, that's going to be your north, and then you have the magnet here. Here's the permanent magnet. Here's the permanent magnet. Here's the permanent magnet. This is the temporary magnet, because if you remember, this is not truly a magnet. It is created to be a magnet with the electrical current. So if you reverse the current, you're going to have repulsion, and therefore the speaker is going to move in this direction. The speaker goes out. Okay, so we've talked about music before and mathematics. When it goes back and forth once, we have one oscillation. So when it goes back and forth in 1 second, that means we have one oscillation. That's actually equal to 1 hertz. It's 1 per second, 1 oscillation per second, so it's 1 hertz. Well, if you wanted a low C, if you wanted your speaker to play a low C is about 256 hertz. What does that mean? That means that you have to have this system where the current switches back and forth 256 times per second. So to get 256 hertz, to get that low C, the current switches back and forth. Current switches back and forth 256 times. Okay, that's the structure. So what happens if you increase the current? If you increase the current that runs through here, you're going to have more electrons going through. You can probably imagine that that's going to increase your electromotive force. We previously had this equation where we have the force is equal to the magnetic field times the strength of the current times the length of the wiring. If you increase your current, you're going to be increasing that force. If you increase that force, you're going to be increasing the movement. And if you increase the movement, what happens is you're actually moving the speaker not just in and out with a certain frequency, but you're moving it out more. Okay, here's your pressure wave that's coming out. Okay, you can have the pressure wave coming out at 256 hertz and it moving just this tiny, tiny, tiny amount. And that's going to give you your low C, but the volume's going to be low. When you increase the current, this is going to be moving much more. It's going to be creating these stronger pressure waves. Those pressure waves have more energy, more movement. That's going to increase your loudness. So that's how you adjust the volume on a speaker. It actually increases the amount of current. Adjusting the current has no effect on changing the frequency. That is due to the switching of the current back and forth, the number of times per second that's needed to produce that one note.